All right, welcome. So our next speaker is Todd Owen. He spent 4 years working for the WA Health Department doing Python development, Unix administration, and working with Ansible. So as of this year, he's started at the Commonwealth Bank with working on big data analytics. And today, his talk is called Ansible, Simplicity, and the Zen of Python. Please welcome him.
Hi, it's great to see such a huge DevOps track in this year's PyCon, starting with Marcus and Owen in the morning and even going through in this room into the sessions after lunch as well. If you are into that kind of thing, you might like to know that we're hiring in the Analytics and Information team at Commonwealth Bank. We've got a couple of Hadoop clusters that need some love and care. So if you'd like to find out more, just grab me by the arm or by email. My address will be on the last slide today. Let's start with a koan. In a faraway land, there was a temple on top of a mountain running a number of Linux servers. One day, the master approached one of the novices and asked him to uninstall some rarely used packages, such as Python 2.x, for the monks in their wisdom had already ported their scripts to Python 3. On the first day, the novice read all about Puppet. On the second day, he installed the Puppet master on the control machine and the agent services on the managed hosts. On the third day, he set up SSL certificates so that the agents could communicate with the master. And on the fourth day, he wrote a Puppet manifest specifying the removal of the unwanted software. On the fifth day, he said, "Oh, wise master, is it not awesome that modern tools can automate a laborious manual process in just 4 days?" By way of reply, the master typed the following into a bash prompt. This means for loop over list of hosts coming from this file, temple hosts, for each one, connect via SSH. If this is set up properly, you won't need a password. Execute as the super user. A command to tell the apt package manager to uninstall Puppet and all of its configuration. End loop. Suddenly, the novice was enlightened. This short shell script basically does what he spent 4 days setting up. So yay for bash, but what was the title of my talk again? You may be wondering when I'm going to tell you about Ansible, or this mysterious Zen of Python. Well, my next slide contains my first references to both. It's a cow. The cow is an Ansible joke. It's not particularly profound. I won't explain it here. The Zen of Python, on the other hand, is either profoundly meaningful or just a comical Easter egg, depending on your taste. The Easter egg being that if you type import this into Python, then it will reveal the Zen. This is line 3 of the Zen. Simple is better than complex. And I'll just clarify what simple means in the context of the story that I was just telling. A sysadmin running a script that connects to other servers and executes some commands there is an example of a push model. Puppet is the reverse. The agents call back to the master every 30 minutes by default to check whether their configuration manifest has changed. So that's an example of a pull model. Now, for some problems in computer science, the pull model may turn out to be superior and more simple than push. But in this particular scenario, I think it's clear that the push model is the simpler one. I mean, some of the added complexity with the pull are managing the services on all these hosts, scheduling pull events, and also monitoring errors in a distributed system. Now, finally, it's only taken me 8 slides to get here. What is Ansible? Well, it's an IT automation tool. So it competes with the likes of Puppet and Chef and CF Engine and Salt and Fabric. You may wonder, did the world really need another one? Well, barely 3 years old, Ansible is the newest kid on the block. I believe it is slightly newer than Salt. But it is seeing phenomenal growth. OpenSource.com called it one of the top 10 open source projects of 2014. And the ThoughtWorks Technology Radar promoted it to the Adopt Circle mid last year. making it the first tool in its class to reach the inner circle of the radar. Oh, and it's written in Python. Ansible's most remarkable feature is its simplicity. For a start, it adopts the same push model that I just described. There are no services to configure on any of the hosts and no software to install anywhere except on the control machine. The sysadmin writes an Ansible playbook and runs it using Ansible. Ansible connects to the other hosts via SSH and executes the tasks from the playbook. And the building blocks of playbooks and tasks are Ansible modules. So for example, there's a module called APT for managing packages on a Debian-like system. So the shell script that we just saw earlier would look something like this with Ansible. Hosts, all, sudo, yes, and then under tasks, we provide a list of modules with parameters. So here we're calling the APT module, passing it the name of a package, puppet, and a target state, absent. I think it's pretty self-explanatory. You might just wonder how it knows which hosts to connect to. The answer is that Ansible requires a separate file called an inventory. But at its simplest, that is nothing but a list of host names, one on each line. Just like the file that the shell script read earlier, there was a file temple hosts. And we can, in fact, reuse that file directly by just passing a -i option to Ansible. So the format, obviously, of a playbook is very different to a shell script, but they contain essentially the same information. There's no, compared to that vanilla bash script, there's no added complexity here, which is why I say that Ansible is simple. Now, this is PyCon, and I don't want to just drone on about the Zen of Python without talking about Python, the language, as well. Is Python simple? Well, let's, as a counterpoint, start with a hello world in Java. Compared to this, Python eliminates visibility modifiers, type annotations, compulsory classes for functions, even compulsory functions. Those things are really orthogonal to the actual purpose of a hello world program. If we took all of that out of Java, then what we're left with is almost as simple as the canonical hello world in Python. That was referred to in the keynote this morning, in fact. A simple hello world. So Python really is very simple. Now, just getting back to where we started, what did we just do? We took a line from the Zen of Python. We saw how that is embodied in Ansible, and then related this wisdom back to Python itself. Now, today I'm not going to cover all of that pattern is one that I'm going to repeat several times, but I'm not going to cover all of the 19 aphorisms one after another. I'm going to touch on maybe a third of them. I'm not going to do them in a given order either. But some do need to be read in pairs. And the line that comes after simple is better than complex is complex is better than complicated. Now, hang on. Doesn't complex and complicated mean the same thing? Well, if you ever meet Tim Peters, who wrote the Zen of Python, then you can ask him. But my opinion of this is that it's an expression of Occam's razor, where a complex system is one that has many elements, but those elements are all necessary. Because it's the problem being solved is complex. So in relation to that problem, these elements are necessary. I think the word complicated here is meant to imply the introduction of unnecessary elements into the system. So let's just turn back to Ansible for an example. And we'll look at how Ansible, I hope that's not very clear. I haven't got too much blue writing, don't worry. We'll look at how Ansible interfaces with the package manager. We just touched a couple of times on APT. Now, the APT module in Ansible is pretty much a thin wrapper around the APT libraries provided by the operating system. And that's the package manager used on Debian-like Linux distributions, but other systems use different package managers. for example, yum. And in Ansible, yum is just a different module. APT and yum are themselves both complex systems. And when you're writing an Ansible playbook, you really should know exactly what you're dealing with. But Puppet, on the other hand, has a different approach. It has a single resource type called package, and APT or yum are different backends called providers. They, in turn, interface with the native tools. So under the covers, it will still be calling some APT command, but Puppet adds this extra layer of abstraction. Now, I sense that some people in the room may be starting to get uncomfortable here. And that's okay, because I was too. Because when I put on my software engineer hat and I look at these two diagrams, which one is more elegant and more extensible, just more intellectually satisfying? Admittedly, it's the one on the right. But the Zen of Python says, no, that one has more moving pieces, more plumbing, more layers. Therefore, it's not merely complex, it's complicated. Now, I'm not saying that abstraction is a bad idea in general, but I think the test should be, does it simplify the design and use of the system? And in this case, I don't think it does. At the very least, different distributions, different systems have different naming conventions for their packages. So as a user of Puppet, I would still need to understand these platform-specific differences. It's a leaky abstraction. Now, Ansible's more straightforward approach to platform-specific differences has a direct parallel in the Python standard library, where there are whole modules to give access to platform-specific features, such as the Unix groups or the Windows registry. Java, on the other hand, Guido van Rossum, writing about the origins of Python, has explained that one of his goals was to support and encourage platform-independent user code, but don't cut off access to platform capabilities or properties. Now, comparing that to Java, Java tries much harder to be platform agnostic. Astonishingly, versions of Java released between 2000 and 2004 did not allow programs to read environment variables because Sun considered those to be system dependent. They did cave in and caved into popular demand, really, and re-enabled that feature in Java 5. Koan 2. A novice sent the master a zip file containing his source code. The master emailed back, asking the novice to meet him in the chamber behind the room at the end of the corridor through the wooden door west of the cypress tree in front of the hall. The novice, of course, didn't know which chamber the master was referring to, so he quickly ran out to the hall, found the cypress tree, went west to a door, through the door, down a corridor, across a room, and found himself in the master's office. "Oh, wise master," he said, panting, "why didn't you just tell me to meet you in your office instead of sending me to 5 other places first?" The master asked him if he knew the significance of the number 5. The novice shook his head. The master said, 5 is the depth of meaningless subdirectories I had to navigate in your zip file. Suddenly, the novice was enlightened. Flat is better than nested. This principle refers to naming things. For example, Ansible modules are not organized hierarchically. The module to extract files from an archive is simply called unarchive. And if you looked at the source code for that, which of course is written in Python, you'd see that it imports a Python module from the standard library called zipfile. If we compare this to the .NET platform, you'll find similar functionality in system.io.compression under the cypress tree in front of the hall. So that's an example of nested as opposed to the first two, which are flat. Now, I'm actually glossing over an interesting technicality here, which is that when you call unarchive, it does actually do something. The other two are really namespaces. So when you import the zip file module, you don't expect that to do anything. You just want to get access to what's inside of it, right? And the real functionality is in a class inside zip file also called zip file, mixed case. And similarly, in system.io.compression, there's a zip archive class. Now, I wonder what the Zen of Python has to say about namespaces. It says namespaces are one honking great idea. Let's do more of those. So by all means, if you have lots of names, put them into namespaces, but just don't nest spaces inside of spaces inside of spaces. Now, Ansible uses namespaces, but only very judiciously. The only place where they're really compulsory is for roles that are shared via Ansible Galaxy, which is like the equivalent of the Python package index for Ansible roles. Here, the username of the author becomes a compulsory prefix for the role, so it serves the purpose of a namespace. Last time I checked, there were 3 roles on namespace, on Galaxy named Django, but this namespace makes them unique and unambiguous. So I think that in this particular context, a namespace really makes a lot of sense. Koan 3. The master was comparing 2 similar programs written by 2 different novices. Both of them expected tab-delimited input files, but the master's data was separated with commas. The master said, "A wise program bends like the bamboo, adapting to new input formats. The first program is flexible because it accepts the delimiting character as a parameter, whereas the second program only splits on white space." The novice who had written the second program leapt to defend his script. "Oh, not at all, wise master," he said. "My script uses the venerable IFS environment variable, the same one that all Unix shells use to determine the internal field separator." "Did you not notice the README file, which explains this all clearly and with use cases?" "Yes," said the master, "I did notice the README, but I did not trouble to read it." Suddenly, the novice was enlightened. Can you guess what the lesson here is? Explicit is better than implicit. For the engineer inside of me, this is another confronting statement. We often think that concise code is beautiful, so we're always looking for ways to reduce the number of calls we have to make or cut down the number of parameters to a function. Making things implicit means they become invisible, at least at the point where you invoke the operation. So it's a tempting way to sweep some of the clutter under the rug. But do be careful, because that more terse code can be more difficult to understand and more difficult to refactor. Simple does not necessarily mean shorter. Let's have a look at how Ansible favors explicit over implicit. Here we're writing a task. We're giving it a descriptive name, which is optional, but a good practice. Verify Python 3.x is the default. The actual Ansible module that we're calling is called command. It runs an arbitrary command, in this case Python -- version, which prints the Python version to standard error. Now, usually if the program succeeds, then this task passes. But we would like to change that so that if the version is not Python 3.x, then we fail the task. To do that, we need to use a register. Register is another option for a task, which assigns the result of the module to a variable. And then we can write some custom logic for the failed when option, like this. So we've got 1 line to assign a variable that we just use in the next line, 2 lines to check a relatively simple condition. It does seem a bit verbose, especially if you find yourself doing this a few times in a playbook. What are the alternatives to this? What if, hypothetically, Ansible had some magic variable? By that I mean a variable whose value is set automatically as a side effect of an operation. Let's call this hypothetical variable res. So now we wouldn't need the register option at all. We just refer directly to res.standarderr. That seems to make it a bit simpler, right? But does it really? What if we also wanted to take this version number and copy it to a file? We'd have to add another task to do that. And then this res, the second res, does it refer to the result of the first module or the second module? So you see, Ansible's approach of requiring this very explicit register option eliminates these sorts of edge cases. Overall, it's more consistent. Python itself doesn't have any magic variables. That distinguishes it from a number of other scripting languages, including Perl, Ruby, and of course the Unix shells. And now we've come to a turning point in my talk where I want to get a little bit more philosophical. The inspiration for my talk today was the realization that Ansible and Python share a similar design philosophy. They're both simple, consistent, and I think almost as a corollary of the Zen of Python, also easy to learn. And I think that the recent popularity of Ansible, as well as the vitality of Python as a language, are due in a large part to these characteristics. So how did Ansible come to be simple? Was it just some happy coincidence? I don't think so. Michael DeHaan is the lead developer of Ansible, and effectively its benevolent dictator for life. This is his GitHub avatar. Some of the words he's used to describe the vision for Ansible are radically simple, easiest config management system to use ever. And I lifted these directly from the README from version 0.0.1 of Ansible. So you can see it's not just an afterthought. You may have encountered the paradox before that simple is actually really difficult to achieve. And I think that if you don't make that a top priority right from the outset, then you don't have a chance. Frankly, I don't think a lot of software projects actually do that. It does certainly help if you have a leader who has a very clear vision and the determination to see it through. In the case of Michael, I've read some of the posts that he's written on the mailing list and on GitHub issues, and his commitment to simplicity really comes through quite strongly. His response to new feature requests is often to point out a simpler way to achieve the same outcome. And he said a few times that while the Ansible project is keen to accept contributions, they also reserve the right to turn down pull requests that don't fit with the Ansible vision. Now, intuitively, that's a good thing, right? Because if you want something to be simple, you'd better not add too many features to it. That's an easy conclusion to jump to, but it's wrong. I don't have time to really go into depth as to why this is, but if I did, I'd just be rehashing some of the arguments put forward by people like Stack Overflow co-founder Joel Spolsky and former Apple VP Don Norman. They say that this choice between simple and features is really a false dichotomy. Features are not your enemy. Indeed, if you stop shipping new features, then your product is pretty much going to die. Simplicity really means that the new features you're adding fit into a consistent mental model for your users. In the words of the Zen of Python, special cases aren't special enough to break the rules. So by all means, listen to your customers and your stakeholders, but don't let their specific demands dictate the actual overall design of your software. Because they don't care about the big picture. I don't blame them for that. They just care about their particular use case. And I'm sure my idea of simplicity is not a whole bunch of different people's special cases kind of joined together with duct tape. That may be an accurate kind of description of a lot of business software. As the founder of Ansible, Michael DeHaan knows that simplicity is not the norm in our industry. He has said of the Ansible project, we're simplifiers. We're seeking a whole new technical aesthetic where much of the software industry has been adrift. And what is aesthetics but a definition for beauty? So I'd like to end this talk with the first line from the Zen of Python. Beautiful is better than ugly. Now, beauty is hard to define and subjective, but I believe that programming language communities, such as the Python community, converge on a shared set of aesthetic values. In the case of Python, we value simplicity, minimalism, and pragmatism. And that, in my humble opinion, is the Zen of Python. Thank you for listening.
much, Todd. Questions?
Hi, Todd. Most of the examples that you gave of Ansible in use were, they seem to involve state transitions, like saying you need to follow these steps to get to the system to a particular the state that we desire. Does Ansible have facility to say this is what a system should look like, take care of it, or is it all these are the sort of the recipes that you need to follow to get to where we want to go?
Oh, thank you. That's really an excellent question. It's something that I thought about a bit, because in my new job, we're actually working a lot in Scala, which is a functional language. And obviously, Python is an example of an imperative language, so there's kind of this rift between functional and imperative, where functional is the more declarative sort of approach. No, Ansible doesn't support that kind of declarative configuration management. And I think that that is, in fact, in line with the Zen of Python and simplicity, because just as when you ask a person, how should we set up this box, they don't go and kind of write a sort of mathematical formula for how it should be. If you ask just an ordinary person, they give you the steps. We should install this and then we should do that. Actually, maybe servers aren't a good example, but when you ask an ordinary person, how do I get to the bus stop? Then they're not going to give you a declarative answer. They're going to give you a step-by-step answer. And so I think that Python itself has chosen the simpler route of an imperative programming language. But where does kind of a declarative nature come in? In Python, you can see it in things like list comprehensions, which are quite declarative in nature, and they tie in very strongly with a functional approach. And in Ansible, when you look at the actual tasks, like the tasks themselves, they're quite declarative, where you, instead of, like in the shell script where you have the apt get command line, you have a module where you're telling it, the state equals absent or state equals present, and this is the name of the package. And at that much lower level, I think it's declarative.
I've got a few kind of random machines at work that I administer because there's kind of no one else to do them, on the order of like 5 or something like that. And they don't have any kind of config management thing in there at all yet. A lot of the tools I've seen kind of rely on building them up from scratch using that tool. Can I just roll Ansible in over the top of my existing setup, or do I need to start those machines from scratch?
You can definitely just pick something that you want to do, and where you might have previously had a checklist of things to do or a bash script, it's very easy to translate that into a playbook, which kind of goes back to what was just being said, that Ansible is very much, it's an IT automation tool. It's not, here is the formal specification for what my system should look like. It's about automating things. And so it's very easy to make that transition. And this is where Ansible is very easy to learn. It's very easy to make that transition from manual steps to, say, scripting to an Ansible playbook.
Thanks very much for your talk. I noticed that you read the README well at the end, so well done with that. So you talked about the Zen of Python and obviously the Zen of Ansible as a consequence. What issues have you encountered with it? Anything that you would change, or everything's perfect? Do you mean with
Ansible. The Zen? Or with
Ansible in particular. Any major issues, or it's all just perfect, no issues on the bug tracker?
Oh. So one thing this is actually, in a sense, reinforcing the point of the Zen of Python. But I think that one of the things that really should have a lot more signs and warnings around it are role dependencies. I actually didn't talk anything about roles in the context of Ansible. They're sort of a step on from playbooks where you want to modularize things a bit. A role is like a sort of a reusable snippet of a playbook or something. But Ansible in version like maybe 1.2 or 1.3, it introduced role dependencies, where you can say this role requires this other role to have been run first. And then in your playbook, you just put down role A, and when you run it, it goes off and runs this other prerequisite role first before role A. And like a lot of people were asking for that, and I went down the route of trying to use that because it is the thing that we software engineers kind of like. And I had a lot of headaches with that. And I actually, later on, I saw a post by Michael DeHaan himself who was saying he thinks people use these role dependencies a lot more than they ought to, and that in a lot of the consulting work they do, they don't use role dependencies at all. So I just think that that should be much better, much more, like there should be warnings about where it's appropriate to use that and where it's not.
Being on the back of the SALT talk, there are obvious juxtapositions, and just one, it sounds to me like Ansible does a reasonable job of taking a sequential serial list of instructions and wraps it up in Python, makes it perhaps a little bit more expressive, a little bit of abstraction, but basically it's just running that sequence. It felt like SALT gives you more opportunity to respond to changes in state from what's happening outside. For example, to bring up a collection of web servers or a multi-master database, wait till it's up. When that's up, then progress to further modifications of the system. It sounds like that's deemed too complex to warrant being supported by Ansible. So that's just my impression.
Yeah, okay, yeah, that's another challenging question. Thanks. I'll start with your first statement that it's just like running a set of steps. It is a bit more than that. It certainly has a strong notion of idempotency. If, you know, it knows whether something has to be run again or whether it's already configured. So you can run a playbook a second time and it should go through and say, you know, everything is already like this, nothing has changed. And on top of that, you can add what are called notifiers, which are like, if this has changed, then you have to do this other thing. Like if I've changed my Apache config, then I have to restart the Apache server or something like that. But that kind of orchestration that you're talking about, where you wait for some service to come up and then respond to it, yeah, it's not really obvious how you would encode that in Ansible.
I was going to say, it's not really obvious, but you can do it, and it's really quite effective when bringing up services, waiting for ports, waiting for ports to open, etc., before continuing on. So it's definitely something that you can research and
Right, yeah. So that's kind of the simple way of doing it is if you need to wait for some server to come up, then yeah, there is a module called wait for. You just basically stop in your playbook and wait for that to happen. And you might think, oh, but that's inefficient. I could be going off and doing something else at the same time. It does work over multiple servers in parallel. So they will all stop. If you're setting up 10 servers and you get to the point where you're starting off the web server, and then you can wait for all of them to come up. And so you've still got this step-by-step notion, but you can have some degree of, that sort of, it's not really orchestration, but yeah, that's very effective for the sort of 80% cases, yeah.
So my question was more probably to do with simplicity, complexity. So when you're stepping into role, deeper into roles, that crossover between creating a complex role with many steps and then creation of a module. Is there a point that you could define as the point where you move from role into write a module to do the same function? It's
a good question because there were a lot of modules I would have liked to write, and because of time constraints, I didn't write any modules.
Yeah.
It's much easier to write a role. But I guess I would say if you think other people would find your module useful, then and you have the motivation and the time to do that, then it can be really useful. I guess I don't have any specific guidelines on that crossover point.
Alrighty, thanks.
Yeah, I'm afraid that's all we have time for. I'm sure you can swamp Todd over lunch. Thank you very much.
Thank you.